In this video, I'm going to be talking about the superposition principle. So I'll first state what the theorem is, what the superposition principle is, and then do an example. So if the function y1 is a solution to this differential equation, ay double prime plus by prime plus cy equals some function f1 of t, and y2, so y2 might be some other function, and this is a solution to a differential equation that looks really similar, so I got the exact same thing on the left-hand side, but the function on the right-hand side might be different. So I'm calling this f2 of t. Then it turns out that when we sum y1 and y2, so y1 plus y2, this is going to be a solution to the differential equation where the right-hand side is f1 of t plus f2 of t. Okay, and we can use this in conjunction with the method of undetermined coefficients to determine the form of a particular solution when the right-hand side is a sum of functions of different types that we can handle with undetermined coefficients. So let's do an example. So I want to guess the form of a particular solution to the following non-homogeneous ODE. Okay, so I have y double prime plus 5y prime minus 24y equals, and then we have e to the 3t plus t to the 4 on the right. Okay, so let's begin by finding the homogeneous solution. That would be our first step. So I've written down the differential equation one more time. I'm just going to say what the solution to the homogeneous equation is. It ends up being c1 e to the negative 8t plus c2 e to the 3t, because the roots of our auxiliary equation end up being negative 8 and 3. Okay, so now I need to guess a form for the particular solution. So notice that the right-hand side is the sum of functions of two different types. So I'm going to call this first exponential function f1 and this polynomial function f2. All right, so we need to formulate a guess for each piece. So I need to form a guess for f1 of t. So f1 of t is e to the 3t. So for e to the 3t, the guess that we'd make, I'm going to call this y sub p1 because I'm going to need another particular solution for f2, for the function f2. So that's why I'm going to call this y sub p1. So when we have an exponential function like this, I would guess something of the form a times e to the 3t, where a is some undetermined coefficient. Okay, now we have to ask ourselves, does this overlap with the homogeneous solution at all? And it does, because I see e to the 3t as one of the functions here, and that's exactly what I have here, e to the 3t being multiplied by a scalar. So this overlaps YH, and we're sad about that. We've seen before that means we have to multiply our guess by t and see if that'll fix it. So let's make a better guess. So a better guess. So let's try yp1 is equal to a times t times e to the 3t. If we look at this, now there is no overlap with YH. And again, even though there's an e to the 3t in both of them, they are not just scalar multiples of each other. Like this underlying function here technically is t times e to the 3t. And that's linearly independent from the function e to the 3t. So that's why there isn't an overlap. Okay, so there isn't an overlap, so we are happy. Okay, so we've got a good guess for f1. Now let's focus on a guess for f2. So a guess for f2 of t. And f2 of t is equal to t to the 4th. So what would our particular solution form be? Let's call this y sub p2. Well, t to the 4th is a 4th degree polynomial. So I should guess a 4th degree polynomial. So I'm going to guess something of the form b0 plus b1t. Actually, let me go and reduce in descending order of power. So let me go b4 t to the 4 plus b3 t cubed plus b squared t squared, sorry, b2 t squared plus b1 t plus b naught. All right, so that's our guess for F2. And this definitely doesn't overlap YH at all because it's a completely different type of function. This is polynomial, YH was exponential. Okay, so let's write down our guess for the sum. So what would our guess be for F1 of t plus F2 of t? Well, our guess, which I'm going to call YP, is going to be the sum of these two individual guesses, YP1 plus YP2. So if we write down what that is, YP would be the sum of these two things. So our first guess was a times t times e to the 3t. That was for the exponential part. And for the polynomial part, we have b4 t to the 4 plus b3 t cubed plus b2 t squared plus b1 t plus b naught. And that's the form of our particular solution. This is what it would look like.